Hey everyone, so picking up where we left off, we are going to look at somewhat more complex versions of the SQL code that we wrote in the last video, and then we'll add a few new commands. So let's go over to our module. And those of you who did not watch the last video, I do recommend it. It's not even 20 minutes long. However, if you don't, what you need to know is that this is the entirety of the code that we wrote. So you're going to wind up seeing a review of most of it anyways. So what we're going to do first is going to create the table again because I want to point out something that I didn't in the last video. So let's go ahead and run our module. We open the table, we go to View, we go to Design View. The field is selected, and down here you'll see field properties. So the field properties down here correspond, of course, to whatever field is selected. Now this is a short text field. So it has this attribute of 255 characters. The reason why this is relevant is every time you add a new record, Access will reserve enough memory in order to accommodate those 255 characters. So even if you only put 10 or 20 or 30 characters, Access has reserved enough memory for 255, and we'll do that for each and every record. So in a small database, this isn't a problem, but in a large database with lots of fields that are text and lots of records, that 255 starts adding up. So you have lots and lots of reserved memory that isn't being used, so it creates bloat and could impact the performance of the database. And also, to the best of my knowledge, Access has a 2 gigabyte limit. Not sure if that's still there, but for years, there's a 2 gigabyte limit for Access. So if it's reserving memory, you're going to hit that number much, much sooner. So again, for a small database, not a big deal, but if you're using lots of fields and lots of records, then that starts to add up. So what we're going to do is we're going to look how to restrict that size, because if you determine that you only ever need 30, 40, 50, there's a way to restrict that size and save all that memory. So let's go ahead and close this tab. We'll delete the table. We go back to our module. And after text, in parentheses, put the number 50. We save this. We run it again. Table gets created. We open it up. Design View. There's the field. And now only 50 characters. So you want to be careful because you don't want to do this after your table has already been created and has data, because you don't want to risk cutting off required characters that you've already stored. So make sure you determine ahead of time the appropriate size. Give yourself a little extra room just to be safe. Like say, in this example, you need 40 characters, so you raise it to 50 just in case your needs change. But now you've restricted the size, so not as much memory is going to be reserved for each and every field of this type. So let's close that, and we go back to our module. Now let's remark that out with an apostrophe because we don't. Actually, let's do one more thing. Let's delete this table one more time. And let's also show you how to add multiple fields when you create the table, because when you first create a table, it's highly unlikely you're only going to want one field, because a one field table is pretty much useless. You could just store those values in a text file. You could store them in an Excel spreadsheet. So in all likelihood, you're creating a table that has at least 2 fields. So how do we do that? Well, you just add a comma, and now it's rinse and repeat. Follow the same format. Square brackets with the name of the field in the middle. So square bracket, and let's do EE underscore hire underscore date, close square bracket, space, and this one will be of the date data type. So hopefully the pattern is evident. The square brackets with the field name, the space, and then the data type, and then if you have something else, it's just another comma, rinse and repeat. But now that you see 2, you could easily do 3, 4, 5, 6, and I kind of keep doing more and more examples. Now, I also want to pause and say, if you notice, date here has a specific meaning, has a specific function to access. So you have to be very careful when you're naming fields. You want to avoid one-word names for 2 reasons. So you want to avoid words like name and date because those have specific meanings and specific functions, and you could potentially cause a problem. You might not, but that's why it's called a best practice, that it might not cause a problem, but it could. So that's the first reason why you shouldn't ever name a field date. You would do something like EE hire date, because you don't want to accidentally name a column that is actually a usable function and has a secondary reserved meaning for access. The second reason is that out of the context of this database, suddenly, if you call this just date, suddenly it means nothing. So you export this table, you give it to someone, and they're like, date of what? Hire date, termination date? What does that date mean? So that's the second reason why, and that you want it to be more meaningful, particularly if the data is ever taken out of the database and passed around. That's very common for, say, financial institutions, one line of business, or one group needs to see something that another group actually maintains. So make sure you're naming your fields with meaning, and that is if you export it out of that table, out of context, the name is still self-evident. So EE hire date would be. So let's go ahead and save that. We go back to our form. We go to our table, and sure enough, there are now 2 fields there. So like I said, no need for me to keep going because you've got this pattern now. Okay, so let's remark this out with an apostrophe because we don't need to create the table yet again. We kept it that time. And let's unremark this one. This is where you create a record in the table. So in EE name, we're going to add a record where the value, let's put the actual person's name in this time. So we just hired Samara Morgan. What else do we want to do? Let's also alter the table. So alter table lets you do various things to the table. In this case, you're going to add a column. So whereas this isn't changing the structure of the table, it's adding a record, this actually changes the structure of the table and adds a column, and the column will be EE age. All right, so let's go ahead and save that. And we run it. You get an advisory that lets you know the rows are going to be appended. I mentioned in the last video that there is a way to suppress these. I'll show you that partway through the video, probably towards the end, because it's technically not, well, not technically, it is not a SQL statement, it's just the VB statement. So let's go back to open up our table, and sure enough, we've added the column and we've added a record. Okay, so let's now remark out that one. But we're not going to remark out this one because we're going to run this one again. So we're going to add another record. But let's do this a little bit differently. What we're going to do with this one is I mentioned that you may not want to add a constant. You may not want to add this static value every single time. Maybe there is a value that is the result of a function running. So you want a value from a function to be saved to the table. So what would that look like? Well, rather than doing name, let's do EE hire date, and we'll put in a date. Well, presumably it will be today's date. So date with another set of parentheses after it. So pretty straightforward. Insert into this table, in this field, a row that has this value. And let's go and run it. Again, you get the advisory that the row is being appended. And there we go. We have a hire date. Now, you could say, well, why would you want to add just a hire date? I'm not saying that this is the preferred way to go about adding the value from a date. Because what you can do is you can just create a table, and when you create the table, you can define default values. So generally speaking, when you create a field, there's some exceptions, but when you create a field, often the default value is blank or null. Auto number is an exception. I believe auto number automatically generates a sequential value. But what I'm getting at is you can declare a default value. So would you ever do this? Probably not, because you could just put in, if you're just using today's date, you could set that as a default value right in the table properties. So I just want to throw that out there because sometimes people say, why'd you do it that way? What I do isn't necessarily the best way to do things. I'm just trying to demonstrate how certain code works. You can then take that code and repurpose it for what you need. But date is extremely easy to tell that it's right. So why create some kind of function and not even be certain what the answer is? We know that the date is correct. Okay, so summary, if you're trying to insert a row into a table, insert a record into a table, you don't have to just put in static constant values. You can indeed have a value that is derived or the result of a function. In this case, the date function. Now, the next bit of SQL code we're going to look at is going to be the equivalence of an update query. So if we go back to our form, if we go back up to the ribbon, we click on Create. We're not going to go through the whole process, but if you click on Query Design, there's actually several different types of query. This is the one that we're going to focus on. So as you can see, the tooltip says, make the query update the data in an existing table. Now, typically a query like this would probably be used for a bulk change because you could technically manually go into a table and make a single change, but not necessarily. So the bottom line is there is a record that's already existing, and you're going to change some value in that record based on some criteria. So let's close that since we're not actually going to use that. Back to our module. And now, so the format is the same. You have to use a little bit of Visual Basic. So do cmd.run SQL. So that is Visual Basic saying that you're going to run. What follows next is SQL. So let's just paste this in here so again I don't make any mistakes. So the whole thing has to be surrounded by quotes. So you've got quotes there, you've got quotes there. Update. So like I was just saying, it's the equivalent of an update query. So update what? We want to update something in our table. Now this is a little bit new. We haven't seen set yet. So whereas here we simply say what the value is, here we actually have to say set. So set EE_age equals to 32, and if you notice, no apostrophes. Where, we saw where in the first video, where, and now this should look a little bit more familiar. We've got the parentheses, the square brackets, so very similar to the formatting when you're first creating the table with the fields. So parentheses, square bracket, the name of the field, square bracket is equal to, and again, a value is placed in apostrophes. So basically, where there is a record that has this value in this field, put this value into this other field. So the record or records that have this value in this field will result in this value going into this field for those corresponding records. So we want, so EE_age will update to 32 for Samara Morgan. Let's run this. Again, you get an advisory. We open our table, and sure enough, Samara Morgan is 32. Okay, so that's about all that I wanted to do for this particular video with one more exception. I said that I was going to show you a bit of non-SQL coding. So those advisories, they may be annoying, but if you're running an automated process, you really don't want those to occur. Why? Because the process would stop. It takes an automated process and stops it from being automated. So what you can do is you can suppress those. So just be mindful if you are going to disable these warnings, then it's buyer beware, because you might make a mistake and not know that a mistake has been made. But again, if you're doing automated process, if warnings are being generated, advisories are being generated, then your process is no longer automated. So we'll just paste this in here so I don't make any mistakes, and I can just read through it, but it's incredibly simple. And actually, let's put it at the top. So do command, so again, it's VB, it's Visual Basic, set warnings false. Couldn't be simpler. You are setting the warnings to be not active, to false. So we already saw the advisories as we were running this. So what we're going to do is we're going to delete our table. And we're just going to review the code to see if I have to make any changes. So we're going to create that table. That doesn't generate an advisory. This would generate an advisory if we're adding a value. So a hire date exists, so we can put the date in there. And let's see, we don't have Samara Morgan. I changed that earlier, but at least you knew that this one would create a value. So, create a warning. So you won't see a warning this time. So again, it's just do command dot set warnings false, and obviously the reverse would be do command dot set warnings true. So we'll just save this, and then we will run it. See, the table is so again, the table wouldn't create a warning, but the adding of a record would, and the adding of the record did not. So kind of a double-edged sword, because sometimes you might want to know what you're doing, particularly if you're running like a delete query. You plan on deleting 10 records and it says you're about to delete 50,000 records. Clearly there's something wrong. But again, there might be specific situations where you really have no choice but to shut off the warnings because you don't want an automated process to be interrupted. Okay, so I think that's it for this video. I hope it has been helpful. I will continue to see if there are additional examples of SQL that would be helpful. However, at a certain point, SQL basically becomes, it's not that there's any new statements, so much the complexity of the current statements. So in other words, you might be looking at 2 or 3 or 4 different tables using 2 or 3 different criterias, and then you get your end result. So it's not that there's necessarily a lot more SQL statements so much as learning how to make those, the complexity. Unfortunately, since I don't have a complex database, it's going to be really difficult to do those, but maybe I'll put something into place if you want to see more complex examples of queries. Well, not just queries, but of SQL in general. So I hope this was helpful. Leave a comment if there is something you'd like to see, and I hope you enjoyed it, and have a good day.